Hi guys, this is a video to help you guys work through any issues that you might still have in problems with exponents, and then I've got some that I'm going to make for problems with radicals in the equations, so radical equations, and then problems with exponents that are rational exponents or, fractions. So right now all we're looking at is properties of exponents. So if we are looking at number 1, I don't know how dizzy that's going to make you. We're looking at number 1 first. So ultimately, the nice thing about number 1 is you're just multiplying things. So you are just going to do a 4 times a 4. Oops, a 4 times a 5. I apologize, right? 4 times 5. And then you're going to have x to the 9th times x squared. And remember, when you are multiplying bases, you are, adding those exponents. That's not really working very well. So your final answer is just going to be 4 times 5 is 20, and then it's going to be x to the 11th. Okay? So that is that one. Let's see if it, it's not going to let me make it smaller. There we go. So sticking that over there underneath there so you've got it, and you can keep looking at it. Okay. When we go to the next one, number 2, please remember, guys, that when you are looking at these numbers, the 42 and the 7, you are not subtracting that. You are actually going to divide it. So it's going to be 42 divided by 7, right? And then your variables, you're going to have x to the 2 minus 11, right? And so ultimately, your number is going to be 42 divided by 7 is 6, x to the negative 9th. You are not allowed to have negative exponents, so you actually have to rewrite it as a 6 over x to the 9th. And you leave it like that. And then let's see if this one lets me. Oh no, oh, it's all it's all connected now. Sorry. It's just, I think we're just going to keep building on and building on. All right, number 3, if we're looking at number 3, guys, it does not matter what is inside here. We don't care about all this stuff. It could be the longest, craziest, most ugly fraction in the world, and because it is raised to the 0 power, it is just going to be a 1, right? Anything to the 0 power is going to be a 1. Okay, on to number 4. Your x squared stays the same. And then, guys, the only thing that has to happen is your y to the negative 3. Remember, that's got to go to the denominator, right? So x squared over y to the 3rd power. For number 5, you've got a couple of options that you can do. It is a power raised to a power. So if you want, and I'll try to run through a few of these options because this video isn't too long just yet. So when you do this, you can do power raised to a power. So you're going to have x to the negative 10th. Right? Because remember, when you're doing power to a power, you are multiplying those exponents. But don't forget, you have a numerator and you have a denominator. So it's going to be x to the 3 times negative 2 is a negative 6. Okay? And then you can flip them. I'm going to go like over here. So you can flip them so you have x to the 6th over x to the, not 10 to the 10th. We have x to the 10th. There we go. And so, of course, we're dividing two bases. We subtract their variable, or their exponents. So x to the negative 4th, which is 1 over x, x to the 4th. So you could have done it that way. The other way, and I'm going to shrink this, and it's probably going to shrink the whole thing. Yep, it does. Okay, so then the other way to look at that, if we take a look at this problem again, right, you can actually simplify inside first. So you still have whatever's inside raised to the negative 2, but inside, guys, what is, I keep picking the blue. What is 5 minus 3? Well, that's going to be x squared. And then really, this is power to a power. Remember, power to a power, you multiply those two exponents, so you get x to the negative 4th, which is the same thing that we got. That's a negative 4, sorry. And then that's 1 over x to the 4th. Okay, so just some properties of exponents to help you out if you need it.